In 2019, a team of astronomers moved European Southern Observatory's very large telescope towards B Centauri, which is a single star of two-star system in the southern constellation of Centaurus. They acquired an original epoch observation in which they identified three faint point sources around B Centauri. The brightest point source had a very strange near-infrared color. Those colors were very similar to the colors of exoplanets as seen in near-infrared. At first they thought it to be a background star, but a faint point source like that can also be a planet orbiting around a target star. To be sure, they moved the eyes of very large telescope towards B Centauri again in 2021. This time, they needed to observe if the point source has a common proper motion with the target star. Please remember, B Centauri is an entirely different star. Sometimes people confuse it with Beta Centauri or Alpha Centauri b. In recent observations, they found the bright point source to be sharing a common proper motion with B Centauri. So, this was the clear evidence of its revolving around the central stellar mass. This was huge because they had directly imaged an exoplanet orbiting a massive star. Before this observation, it was believed that planets could not exist around stars this massive and this hot. I shall leave a link to their research in the description. The B Centauri system consists of a close pair of stars. The more massive star is named B Centauri A. The star is observed to have an effective temperature of approximately 18,000 Kelvin, while our Sun has a surface temperature of just 5778 Kelvin. So, this star is extremely hot. No wonder why scientists used to think planets could not exist around stars like this. But the second star, B Centauri b, has been observed to have dynamical influence on its primary star. But there is no full orbital characterization of the system. So, for now, its properties are uncertain. But because of its circumbinary nature, the planet has been referred as B Centauri AB-B, where AB denotes that it orbits both of the stellar A and B components. In simple words, the planet orbits both stars. The total mass of the central pair of the star is 6 to 10 solar masses. This is 2 to 4 times higher than most of the host stars of any other confirmed planets. For the fact HD 1069AB, which is also directly imaged to host a planet, is the next highest mass binary host star with a total mass of 2.7 solar masses. And in terms of single stars to host a planet have masses up to 3 solar masses. The planet B Centauri AB-B is huge. It has a mass of 10.9 Jupiter-sized planets. Usually, astronomers use the luminosity of planets to determine the mass, but this time they did not because it was uncertain. They measured the mass using Markov chain Monte Carlo test, so it is nearly precise. But the planet, even with a mass of nearly 11 Jupiters, has just the mass of 0.10 to 0.17% of its host binary star. Surprisingly, this is very similar to the mass ratio between Jupiter and Sun. Using the mass ratio of a planet to the host star system it orbits, we can understand how it was formed. Though scientists had another study of the same planet from the year 2000 to use as reference. That time, it was not studied to be a planet as they assumed it to be a background containment. But that study helped scientists determine the significant orbital motion. Before continuing, these videos take a lot of time and hard work to make. Please show your support by subscribing and hitting the like button. Most previous large-scale exoplanet surveys have generally centered their attention around Sun-like stars. Stars with more than 3 solar mass range has not been systematically probed with direct imaging. BEAST or B-star exoplanet abundance study is the first study that is directly looking for exoplanet around massive stars. The planet is orbiting the hot star at 100 times the distance Jupiter orbits the Sun. This is approximately 325 light years away. As you learned earlier, the star is over 3 times as hot as Sun. Because of its intense temperature, it emits large amount of ultraviolet and X-ray radiation. Now, the next question you have in mind is if the planet is habitable or not. Usually, B-type stars are considered to have quite destructive and dangerous environments. So, it was believed that it should be exceedingly difficult to form large planets around them. The planet in B Centauri is an alien world in an environment that is completely different from what we experience here on Earth and in our solar system. It's a harsh environment dominated by extreme radiation, where everything is on gigantic scale. The stars are bigger, the planet is bigger, the distances are bigger, and is most likely not suitable for life. But the universe has a unique way of proving us wrong, and we know life can sustain in harshest of the environments. So, life may also thrive there. If it does, then it would be completely different from life on Earth.